Okay. Okay. We will continue. We will continue on the hypothesis. Okay. Sorry. I will go back on the research objective. Okay. So on the research objective, okay. Actually, normally we need to have at least three research objectives. Okay. Okay. So we should have at least three research objectives. Okay. Uh, So research objective are the specific component of the research problem, okay, that you will be working to answer or complete in order to answer the overall research problems. Okay. Okay. For example, if you want to study, okay, on soil stabilization, the the behavior of soil, okay, or the efficacy of soil stabilization, okay. Uh, might be for the first objective, okay, you can put to determine the soil and stabilizer properties, okay. That is the first one, okay. So for example, if you want to stabilize for a lime, for uh, laterite soil, okay. So you need to identify what is the characteristic of the laterite and the stabilizer that you use. Okay, so that is the first objective. Okay, and then you can have another objective. Okay, for example, to determine uh, the uh, the engineering properties. Okay, due to uh, the in, due to the increment of uh, stabilizer agents. Okay, so means that you want to look what will be what is happening to the soil. Okay, after you mix with uh, several amount of stabilizer. Okay, and the last one, okay, to establish a relationship between, for example, uh, shear strength or engineering properties, okay, with the amount of stabilizer. Okay, so that will be the third objective. Okay, so that is the objective that you want to carry out. So all the objective uh, can be measured. Okay, means that you can quantify it by using any methods. Okay, so later on in the conclusions, so you need to list all these objective and put the answer. Okay, what is the soil properties that you gain? Okay, okay, and then what is the increment in terms or the enhancement of the soil properties or soil engineering properties? Okay, and what is the relation that you have gained, okay, from the shear strength with the amount of stabilizer? Is it a linear or non-linear, okay, relationship? Okay, so that is the objective. Okay, so at least you need to have three. Okay, so research objective should be clear and achievable as they directly assist in answering the research problems. Okay, so it is can be achieved. Okay, uh, in your for the research objective that you have put in your thesis. Okay, so the objective may be specified in the form of either statement or questions. Okay, so this is the normal or the usual words, okay, that normally being used, okay, uh, to address the research objective. Okay, So we may discuss later on next week, okay, by show one or two example, okay, on this research objective. Okay. So a hypothesis assumption about relation between variable, okay. So we can understand here that we should have any variable or any parameter, okay, in our study. Okay, for example, if you want to study uh, on the um, on the stabilization, okay. So might be your variable is the strength, the amount of stabilizer, okay, the strength, okay. Or if you want to look on the bearing capacity of a footing or foundation, so you need to identify what is the width, the length, okay, and what is the strength of the soil, okay, the soil properties, and also what is the load that you need to apply, okay. Or you want to conduct for a social science study, you want to look on the age, on the gender, okay, uh, on the career background, okay, or on the education background, okay. So that is the variable, okay. So hypothesis can be defined as a logical conjecture or guesses relationship between two or more variables expressed in the form of testable statement. Relationship are conjecture and on the basis of the network of association established in the theoretical framework formulated for the research study. Okay. So simple example, A is increased when B is decreased. So that will be a difference between two parameter, which is A and B. Okay. Okay. So that will be a guess that on the first place that you put. Okay. Later on, you need to test it, okay, by using any device or equipment. Okay, then you can prove the assumption that you made. Okay. So anything that can vary can be considered as variable. Okay. A variable is anything that can take on differing or varying value. For example, each, okay, production units, okay, absenteeism, sex, motivation, income, height, weight. Okay, so this is example. Okay, the value can differ at various time for the same object or person, or at the same time for different object or persons. Okay. So a variable is a characteristic that take on two or more value, whereas an attribute is specific value on variable qualitative. Okay. So for example, the variable set gender has two attributes, male and female. Okay. The variable agreement has five attributes: strongly, agree, agree, neutral, disagree, strongly disagree. Okay. So this is normally related to, for example, if somebody want to carry out for a project management study, so we normally use this kind of variable of agreement. Okay. So it's very qualitative approach. Okay. So the type of variable, explanatory or extraneous variable, the variable selected for any analysis called explanatory variable, and all other variables that are not related to purpose of the study but may affect the dependence variable are extraneous. Okay. So dependent or versus independent variable, the variable that change in relation to change in another variable is called dependent variable. Okay. So the variable whose change result in the change in the another variable is called as independent. Okay. So normally for the independent, if we create a graph, normally the independent is on what we call it on the x axis, while the dependent on the y axis. Okay. Okay. So that is for the hypothesis. Okay. Because when we discuss on the parameter, okay. So for example, for a quantitative study, okay, we may use this kind of approach where we call as a dimensional analysis. Okay. So for example, we need to identify what is the important parameter, okay, that we need to use or which is related to the problems. Okay. Okay. By using this kind of approach, okay, so we know what is the element, okay, and also we can estimate, okay, or we can propose a number of testing, okay, based on period that we have, okay, time frame that we have. Okay. So for example, if we have 1 year of study, okay, so we may use this kind of approach, okay, so we can estimate how many tests that we can carry out, okay, based on the 1 year study, 1 year period of study, for example. Okay. So for example, for my test, okay, so in order to build what we call as the ground model and install the columns and do the testing, so I need to spend more than 3 weeks. Okay. So 3 weeks. Okay. So in order to consider as a PhD work, okay, so I need to have a total experimental work which cover for more than 1.5 years. Okay. So from there, I need to know how many tests that I need to conduct, okay, to represent for a PhD study. Okay. So for example, for 3 weeks, so we'll have approximately 52 weeks to represent for 1 year for the laboratory work. Okay. And then 6 months more for the numerical works and then include the analysis. Okay. So if 52 divide with 3, okay, so at least I need to have approximately um, 16 tests, for example. Okay, 16 tests. Okay, so that's why in my thesis, okay, I have portrayed 16 tests. Okay, uh, to uh, to 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 say that it is sufficient or suffice or enough works for PhD. Okay. Okay, we try to complete on this part, okay, and then later on we may meet next week, because this is a little bit uh, hard to understand, so I need to explain it in a simple way. Okay. But it's very interesting, okay, if you know this kind of approach, so you can make use it for your research, okay, specifically, or you can use it for your career. Okay. So dimensional analysis is a method for deducing elements, okay, of the form of a theoretical relationship from considering of the variable and parameter that make up that relationship. Okay. So to identify how many parameter which is required as a deducing element, okay, so we need to understand the theoretical background of the problems. Okay, I will share with you later some of example, but it is more related to geotechnical engineering field. Okay. So we need to know the theoretical background, okay, okay, in order to deducing the elements or to deducing the what we call as the parameter. Okay. So dimensional analysis of the problem then leads to a reduction in number of variables that must be studied in order to understand the problem. Okay. So once we know the related parameters, okay, so we can reduce the number that variable that we want to investigate. Okay. So for example, if we have more than 5 parameters, okay, then with, for example, with a 1 year of study period, okay, it is advisable for us to study only 3 parameters. Okay, so that's why we need to know how many parameters that involved in that particular problems. Okay, the key is to create dimensionally homogeneous equation whose form does not depend on the units or measurement. Okay, so the idea is to create a non-dimensional equation, okay, which is doesn't have any units. Okay, for example, what does it mean? For example, strain. Strain is we call as a dimensionless because it doesn't have any units. Okay, strain is a dimensional because changes of length over actual length. Okay, so millimeter over millimeter, so it doesn't have any units. That is, for example, of strain. Another one is Poisson ratio. Poisson ratio we can consider as a dimensionless, okay, because the ratio between horizontal strain over vertical strain, okay, and we can create more, okay, by using this kind of approach. Okay, so governing equation cannot just be plucked from the air. Okay, they must come from an underlying inside the phenomenon that is being modeled. Okay, means that we need to refer to the theoretical equation or theoretical background of that problems. Okay, so the theory of dimensional analysis is encapsulated in Buckingham theorems. Okay, they call as a Buckingham theorems. So Buckingham phi theorem state that if there are n, okay, this is the n variable, which is the number of the parameter. Let's say 9. Okay, 9 is the variable in the problem, and this variable contain m primary dimension. For example, MLT, this is based on the second Newton law. Okay, the equation relating all the variable will have n, which is the number of the variable, minus with m, the number of the primary dimension, dimensionless group. Okay, I will explain later on based on the example. Okay, so we need to create, for example, 9 minus 2. So we need to create 7 dimensionless equation. Okay, so that is the idea. Okay, from this dimensional analysis. Okay. So Buckingham refer to this group as a 5 groups. Okay, so they use the term of the 5 groups. Okay, so the 5 group must be independent of each other, and no one group should be formed by multiplying together power of other groups. Okay, so it means that if we have 9 parameter, so we need to use all these 9 parameter, okay, to create for the dimensionless equation. Okay, so we are not allowed to reuse it again unless when it is necessary. Okay, I will discuss later on. Okay, so this method offer the advantage of being more simple than the method of solving simultaneous equation for obtaining the value of the indice. So that means that this method is more easy, okay, compared to any other method they call as a solving simultaneous approach. Okay, so in this method of solving the equation, there are 2 conditions. Okay, each of the fundamental dimension must appear in at least one of the m variable. Okay, it must not be possible to form a dimensionless group from one of the variable within a recurring set. Okay. So recurring set is a group of variable forming a dimensionless group. Okay. I guess I can explain easy by show the example. Okay, so this is the this is the condition that we need to follow. Okay. Okay. A fundamental quantities must commonly employed are based on the Newton's second law. Okay, which state that the rate of change in momentum of a body is proportional to the applied force. Okay, so this is based on the Newton's second law, which is F equal to ma. Okay, so where F is the momentum, okay, times mass times velocity. So they come up with the acceleration, which is equal to velocity over time. Where acceleration is velocity over time. Therefore, force, okay, is proportional to the mass times acceleration. Okay. Okay. In order to identify the primary dimension, okay, which is either FLT or MLT, so we may use this force equal to mass time acceleration. Okay. So making it of the constant value, the relation of above, if expressed dimensionally, we give F equal to M. M is the mass, acceleration is L times T power by -2. Okay. So we have a dimension of force, which is F, dimension of mass, which is M, dimension of length, which is L, dimension of T, which is time. Okay. So the equation relates 4 dimensions, which is F, M, L, and T. Okay. Therefore, while L and T is the fundamental dimension required for geometry and kinematics, the third fundamental dimension is dynamic. Okay, so we have geometry represent the L, kinematic represent the T. Okay, and then the other one is dynamic, where it represent F and M. Okay, so it can represent either F and M. So we need to choose. Okay, if we want to use FLT, okay, so we may use the force, or we want to use MLT, so we need to use the mass for the dynamic. Okay, the choice of this quantity depends upon the measurement system, whether we want to apply the MLT system based on the SI system or the FLT system based on the BT system. Okay, for my experience, okay, if I dealing with stress, it is better for me to use the FLT because force is related to stress. Okay, but this is suggestion by the author. Okay, I got this from David Muirwood's reference book. However, in this work, since mass is the fundamental physical quantity, the latter are employed in the deriving the dimensionless value of the equations. Okay. So he also agreed that to use the FLT. Because mass is the fundamental physical quantity, so it's better to use the FLT. Okay. So selection of the relevant independent parameter can be quite difficult. The resolution of relate problem requires sufficient experience. Okay, for example, might be person A will produce a different dimensionless equation with person B, and it may depends on what is the interest of person A with and with the person B. Okay, I will explain later. Okay, dimensional associated with Buckingham Pi theorem provide useful hint in determining the various factors that involve in the analysis and the relevant data to be collected. Okay, that is the gist of the dimensional analysis. Okay. Okay, I will show some of example. I guess you may understand later. What is mean with this dimensional analysis? Okay. After we discuss all of this example, then we can end our class. Okay. So for example, slope in cohesive soil. Okay. So an example, the factor safety, okay, that is the output for slope stability analysis, okay, of a slope formed in purely cohesive soil. So we have here Fs. Okay. So that is the output. Okay. Then the input, okay, that normally been used, okay, to examine the stability of the slope in purely cohesive soil. So we have h, which is the height of the slope, theta, which is the angle of the slope, cu, which is the undrained shear strength of the soil, unit weight, which is the gamma is the unit weight of the soil, okay, and the d is the distance between the toe to the hard layer. Okay. Okay. So this is some of the parameter, okay, that normally been considered for the purely cohesive soil of a slope. Okay. So if it does not mention for purely cohesive soil, most probably there will be a phi value. There will the another parameter, which is the phi value. Okay. So we have a phi output, a phi input 1, 2, 3, 4, 5, and one output, which is the factor safety. Okay. So then we list as a n equal to 6. Okay, this is the parameter which is include input and also the output. Okay. So for each parameter, okay, so we need to derive what is the primary dimensions for each parameter. Okay. For example, factor safety. Factor safety is a ratio between stress over stress, which is the driving force, which is the resisting force over the driving force. Okay. So it doesn't have any units. So in that case, we just put as a 1. Okay. So H based on the FLT, okay. So L is represent for the height or geometry. Okay. So we consider as a L. Okay. We put as a L for the primary dimension. Theta, which is the angle, definitely it doesn't have any units. It's only a degree. So we put as a 1. Sorry, the unit is degree, but it doesn't have any primary dimension. Okay, so we put as a 1. Okay, while for this Cu, okay, which is the stress or undrained shear strength, okay, the stress, if in units, it is kilonewton per meter square. Okay, so in that case, kilonewton is referred to F. Okay, meter square is referred to L power by negative 2. Okay, so that is for FL power by negative 2. Okay, while for the unit weight, okay, actually unit weight is the density, but we use the unit weight when we use the kilonewton. Okay, so the kilonewton over meters cubed. Okay, so in the primary dimension, FL power by negative 3 or FL cubes, F over L cubes. Okay, so the last one is D. Okay, D is the geometry, so D is referred to L. So then we count how many primary dimension where the maximum can go up to 3 because we have FLT. Okay, but for this case, we doesn't have any T. Okay, so that's why it's preferred to use FLT when we deal with a force. Okay, okay, so now we have two. M value. So in order to create the dimensional less equation, so 6 should minus with 2, so we need to have a 4-dimensionless equation. Okay, so to begin with, okay, so Fs we consider as a dimensionless, while theta also is dimensionless. So we need to create 2 more. Okay, so to make it easy, okay, so we have used this one, then we use the theta. So this is theta, sorry, okay. So to make it easy, okay, so we may use the ratio between D over H, okay. So we have another equation here, D over H. Then the last one, we should use the combination of Cu and gamma. Okay. However, the Cu and gamma, we cannot solve it unless we should use either H or D. Okay, so that is allowed. Okay, although we reuse or we use again any parameter that already been included in the dimensionless. Okay, that is allowed. Okay, although the first rules doesn't allow to use or uh, repeat using the same parameter, but due to if we not use it, we cannot solve we cannot produce another dimensionless equation, so that can be allowed to be used. Okay, so the last option is to use the Cu over unit weight times H, because kilonewton, okay, when we derive based on kilonewton meter square over kilonewton meter cube. So then it may multiply with the meter because H. So in here we have the same kilonewton per meter square over kilonewton per meter square. So we have 4 set of dimensionless equation. Okay. Okay. So what is the benefit of this approach? Okay. Later on, okay, we can see that this chart or this preliminary chart, okay, proposed by Taylor. Okay, you can look on the textbook. Okay, so this is a relation has been proposed by Taylor. Okay, so they call as Taylor design chart. Okay, so it's normal. Is used, okay, to get the factor safety, okay, of the slope, okay, by using this stability number. We call as this a stability number. Okay, so this is dimensionless 1, this is dimensionless 2, while this is the dimensionless 3. So that is the benefit of using this dimensionless or dimensional analysis. Okay, so it means that although we carry out for a test under a specific size, by using what we call as this dimensionless approach, so we any researcher can use it, okay, although the size of the testing chamber is not same or bigger than the size that been used, for example, by Taylor. Okay, okay. Okay, the four-cone methods, okay. The four-cone used as a quick measure of undrained strength in the laboratory, okay. Although although the four-cone method is normally used to determine the liquid limit for a soil, okay, but it also can be used to determine the undrained strength in a lab scale, okay. So in this case, Okay. The M, okay, has been converted to W because normally for the liquid limit weight of cone is about 80 gram. Okay. While alpha is the angle of the cone, which is normally 60 degree. Okay. Cu is the strength that we can determine. Okay. And at the same time, we also may determine what we call as the depth of the penetration. Okay. So in this case, okay, the output is Cu. Okay. Then the input is D, W, and alpha. Okay. So we have 4 parameters there. Okay. For each parameter, okay, we may identify what is the primary dimension. So L is referred to D, weight is referred to F in kilonewton, Cu is the underlying shear strength, which is Fl power by -2, while alpha, it doesn't have any primary dimension, so we consider as 1. So 4 minus by 2, so we need to have 2-dimensional equation. Okay. So definitely alpha is the first one. And then we need to make use all of these 3. Okay. So then the author come up with the Cu times D power by 2 over W. Okay. So if you use the primary dimension, Fl power by -2, okay, over L power by 2 over times L over by 2 and then times with F. Okay. So this will be eliminate, and also this one. Okay. So then we have this kind of 2-dimensionless equation. Okay. So actually this equation has been used by Wood and Rowe from Oxford, okay, to propose a new way to determine the plastic limit of a soil, because plastic limit normally we use the thread rule methods, okay, or the Casagandre method. Okay. So I also use this when I did my master project, okay, to propose a new way to determine the plastic limit by using the 4 cone methods. Okay, so that is why it's very powerful approach that has been used by several researchers. Okay, on for this example. Okay, okay. The second last one, okay, is the bearing capacity. Uh, uh, where the outcome of the approach is the PU, which is the load, ultimate load. And then for this type of soil or footing, okay, so this is the geometry of the footing, which is B, and the length of the footing, which is L. Okay. Then during the testing, okay, or before the testing, okay, this what we call it, this footing has been installed, okay, under a certain value of D, okay, from the ground level, okay, and the soil properties is C, Phi, and gamma. Okay, so in that case, it has 7 value of N. Okay, so then for each parameter, so we may use the F, the primary dimension. F is referred to PU because this is a capital P, so normally it refers to load. If small letter is referred to stress. Okay, then L, B, D, Cu is the underlying shear strength. Okay, P is referred to internal friction angle. It doesn't have any primary dimension. And the last one is the unit width. So 7 minus with 2, then we obtain 5. Okay, so we need to derive 5 dimensionless equation. So we need to have 4. So we can use L over B, D over B. Okay. So it depends on what interest, what is our interest. For example, if we want to investigate more related to B, so we can have a derivation based on B. For example, for this case, the author used B. Okay, B, and also this is B. Okay. So for example, if we want to look more on the length, so might be this will be B over L, or D over L, or this will be Cu over gamma L. While this is Pu over gamma L power by 3. So it depends on what is your interest. Okay, so that is for the bearing capacity. And the last one is for the vertical cut. Okay, so this is more related to slope, but we look on the vertical cut. We want to cut up to 90 degree. Okay, and then look on the stability. So the factor safety is the output, while the rest is the input. So we have 5 parameter. So for each parameter, we identify what is the primary dimension. Then we have 2. So we need to create 3. So definitely Fs is the number 1. Alpha is number 2. While the rest is based on the remaining parameter. Okay. So that is the powerful of the primary dimension, which is related to parameter. Okay. So this is more related to parameter that we want to investigate in the research. Okay. Okay. I guess that's all for today. I will continue for next week class. Okay. It's already 7. Okay. So sorry for the late. Okay. So until we meet again, I will share the recorded version in the e-learning, hopefully by tomorrow. Okay. Once I have received the feedback from the WebEx, the WebEx will email me regarding this recorded class. Okay. So that's all. Until we meet next week. I guess for next week, our class will be held on Thursday as usual, because tomorrow I have another commitment. So that's why I need to make one a day early. Okay. So that's all. Okay. Assalamualaikum and good afternoon. If you have any problem, you can just text to put any question in the WhatsApp group. Okay. Bye. Assalamualaikum and good afternoon.
Thank you, Prof.
Terima kasih, Prof.